Good morning, everyone. I hope you guys are having a wonderful, wonderful Friday. Good morning, some Piñata. Good morning, Zin Live. Yeah, it's time to get schooled again. And yes, the permadeath tag. You know, Zin, as they say, if you die in real life, you die in the game. So, like, isn't life just always on permadeath mode? You know, we didn't have work at the academy today, you know? It is, apparently they're observing this holiday now called Juneteenth. And this comes 2 days before the end of the school year. So we don't have today at the academy, and then we have 2 days and then the school year's over. I don't get it either. I feel like it's a really weirdly placed holiday to have in the school year. Just let me get out earlier, come on. So technically, this is like the first class I'm teaching today. You also claim to sleep in class. Good night. Also, welcome, Sora. Look, sometimes that's what it is, right? You come into the classroom, you walk in, the teacher starts talking, you fall asleep, and you absorb the information by osmosis. I've had many students definitely learn through that way. And by learn, I mean they definitely didn't learn anything, and I'm pretty sure they just used their phone to get the answers, and I'm pretty sure I've caught them multiple times, but I don't have the energy to stop them. You know, teachers talking about the best ASMR, math ASMR. Do you wake students who are asleep in your class? It depends on where in the room they're sitting. That's the thing, right? If they're sitting right in the view of the window, I kind of have to make a display of it so that, like, if any administrator walks past, then it's gonna be like, yeah, no, I don't want someone to walk in and then just see your whole ass just planted on the desk. Like, I had a student walk into class the other day, and we have these long tables in our classroom. It's like, it seats 2 students. And the kid just curled up into a ball on top of the table. And I was just like, look, kid, I get that you're sleepy. You cannot put your entire body on a table and just sleep, okay? Sleep in any other position, but not straight up on the entire table, like, whole ass. Look, I have to say that because I can't just refer to my students by their names on stream. It would be an invasion of privacy. But like, sometimes you have like some of our classrooms have this like side room that has no windows to it aside from like the windows from the classroom. So teachers passing by, like administrators, wouldn't see it if you pass by. So like if a kid goes into that side room and passes the hell out, I don't see it. They're taking a nap, they're getting their good rest, and you know, I'm not gonna Hey Pigio too, thank you for the follow. Where are my alerts at? How is it not gonna show up? Oh, it's all the way at the bottom here. Let's put that at the foreground. You're here to retain 0 of the information shared today. Here, the reason why you're gonna retain 0 of the information, Conrad, is because I know you know most of the information. I had everyone participating in the Olympiad fill out a Google forum, and I'm pretty sure most people participating in this either have not taken any math classes or have taken more math classes than I have. So that's going to be interesting. That's going to be fun to see. I'm really interested in seeing how I'm going to have to eliminate everyone. I have my ideas to see how people get blown up out of this tournament, but we'll cross that bridge when we get there, as they say. Despite the fact that there are probably going to be multiple people who are better than math than I am here, I will still find a way to wipe you off the face of this earth with precision the likes you have never seen before. Anyway, let's get to talk some. Is it a PvP tournament? It'll be turn-based until we get far enough to the end where I've exhausted all the material. Like, if for some reason we get to like round 10 or 11 and people are still alive, it's gonna be PvP. You thought you were on teams? It's like a spelling bee, you know? It's gonna start off like a spelling bee. Like, every person gets their own problem. I actually started writing out the problems on some of the other topics yesterday. Individual deathmatch. Yeah, so like, everyone's gonna get their problem. They're gonna have to write out the answers. They're gonna have to show their work on the collective whiteboard. And we're gonna see how the work goes, you know? So it's not just like I give you the work and we just don't see anything. The spectators need to see your thought process, so everyone's gonna see the work get written out on the screen. Showing work, exactly, showing work, you know? How are you gonna do the math if you can't explain how you did the math, right? How much RNG is in this turn-based game? I mean, I decided to make all the problems on a pretty relatively normal scale of difficulty. Like, within each topic, there might be some problems that are harder than others, but they're all like on the same thing. Like they're all going to be long division or all multiplication or all solving quadratics, all that kind of stuff. So within the topics, it's going to be relatively similar in difficulty. The answers were revealed to me in a dream, like a nightmare. Anyway, I covered some geometry in Algebra 1 last week along with some basic multiplication and division. Today we're going to go into some Algebra 2 topics, and in the interest of time, I'm only going to cover like 2 major topics from each level of math, because, you know, I feel like I'm going to get on tangents. Like, you know, this is less of me going over the notes and more of how distracted is Elliot going to be telling stories and going on tangents just like you're in a real classroom. Just like you were really learning from a teacher. Anyway, let's talk about something I'm sure we all love and remember. Let's talk about imaginary numbers. You guys all know what imaginary numbers is. Does anyone in the chat know what an imaginary number is? What the hell is I? I? E? What is this? So, the imaginary number, right? Imaginary numbers are a topic that are typically ICUP. Hi, Akio. Imaginary sequences. Dr. Conrad, you shut the hell up. I think, therefore, I am. I can imagine a number. Nah, I think Akio's got the right answer. He just spelled out I cup. But the imaginary number I, it represents the square root of -1. Because, as you may or may not know, I don't know how far removed some of you guys are from math, you can't take the square root of a negative number, right? You can take the square root of any positive number, right? Like, say, the square root of, like, say, 25. We know that the square root of 25 is plus or minus 5, right? 5 times 5 is 25, -5 times -5 is 25. But there's no way we can multiply a number by itself and have it turn into a negative. What happens if you do? What happens if you do what? If you cup? If you... I don't even want to spell it out. Welcome, Sora, and welcome, Auxilla. You're not late, you came in. Look. I have students in my last period classes. That class starts at 1:23. On a regular day, I think I have my full class attendance by 1:35. Maybe not even 1:35. Sometimes like 1:40. Like, these kids just really like take their time to get to my class. And it's probably because I don't mark them tardy, because I don't care enough to mark them tardy. But they definitely like take way longer than they should. I'm pretty sure they're socializing in the halls, but being 10 minutes late to class isn't too big of a deal. It's alright. We can't take the square root of a negative. Can't square a negative number normally. Let me not try to squeeze everything into one line. You know, sometimes you just want to fit everything onto one line and you're like, no, I am gonna have to skip to the next line for just one word. Complex numbers are lame. Quaternions are... I'm not even gonna get into that. I don't want to think about that. I feel like my soul's leaving my body. Math, my biggest enemy. It's alright. Once you see these lessons, you're gonna be like, wow, math is easy. I should be able to ace all these questions on these topics tomorrow. You'll be fine, Zin. So, we need something to represent it. Represent that idea. Right? So the value of I, right? The value of I simply just represents the square root of a negative number. So if I were to say, example, let's say we took the square root of -25, right? Like I said earlier, the square root of 25 is just plus or minus 5. But with this negative inside the square root, all this means is that instead of saying the square root of plus or minus 5, you would say that it's the square root, or the square root of -25 is plus or minus 5i. I actually don't know this, but when you take the square root of -1, would it be negative I or positive I, or does it actually not matter? It's both. Oh, yeah, no. Like, when you do the quadratic formula, right? When you do, say, like, if you were to, like, solve something like, say, x squared plus 2x plus, I don't know, let's say 5, right? When you plug that into the quadratic formula, your answer is going to be -4 plus or minus the square root of 4 minus 4 times 5, something like this, right? Over 2a, so it's 2. You end up getting -4 plus or minus the square root of -16 over 2. I made this actually a whole number, over 2. Or, since it's -4 plus or minus the square root of -16, that just becomes -4 plus or minus 4i. So that whole thing, right? The plus or minus happens because we're taking that square root. So it's the same concept with like just taking a square root normally. When you square root a number normally, like you say you just ask for the square root of 64, the square root of 64 is plus or minus 8, right? And you will typically work with the positive one, but there's not really a lot of situations in math, at least at the high school level, where you have to worry about whether or not it's plus or minus. Usually when you're working with complex numbers and like that kind of stuff, they give you the sign already without having to take the square root. Or if you are taking the square root, it's just implied that you're going to have that plus or minus. So it's not something that really matters all too much, right? Like when we work with regular square roots, we usually have the context with us to know whether or not we need to consider the square root being negative, but typically we just default to it being positive. It's sort of that same kind of idea here. That's all an imaginary number is, right? If we have the square root of -1, that turns into I. And then there's that funny little chart, right? You know, if we have this, right? Imaginary numbers continued. NTD. So if I is equal to the square root of -1, then we have to consider what happens when we square a square root, right? Typically when you square a square root, the exponent and the root cancel each other out. So what that means is that I squared is equal to the square root of -1 squared. And this is really where the concept of imaginary numbers becomes important, right? A lot of times, like, in high school and really, like, early college, you're not going to really deal with funny shape mean math, hype up. You're not really going to have to worry about working with negative square roots. It isn't until, like, I want to say, like, Calc 2 or 3, where you get into three-dimensional math, that you'll start seeing imaginary numbers more and seeing them sort of cancel each other out. The purpose of this is that sometimes there will be situations where you take the square root of... Sorry, let me British for a moment. Maths. Okay, pup. Yes, we are doing the maths right now. But a lot of times, most problems involving imaginary numbers will end up squaring themselves out, so they'll turn into... whole numbers. Hi, Jones. Thank you, nerd. You know how to deal with I until you go into the funky thing called alternating current. God, don't even get me started with physics, Caleb. Also, welcome, Caleb. Like, I took physics 1 and 2 in college, and I'm pretty sure I slept through that class. I astral projected through all of physics and got an A-, and I remember gravity, I remember acceleration, I remember, like, a lot of motion problems. I don't think we got too much into circuitry. I think we did, like, force problems and, like, elasticity, but I don't remember doing any... No, you didn't, pup. No, you didn't. You didn't see me buying a plushie yesterday. You see a lot of differential equations. I did a couple semester of electrical engineering in college, and that sounds terrible. Look, I like being in my safe conceptual maths a lot. Scientific math, applied math scares me too much. I just want to teach, like, high school classes. I never signed up to do anything. I never signed up to actually understand the material beyond that. Yeah, I also don't think I've taken differential equations, but I feel like every single person that I've talked to that is a math major took differential equations. It looked like you with some nice legs. No, it's just a lookalike. You know, I get it a lot that there's a lot of people who look like me, so you probably just saw the Mr. Ambers lookalike. Anyway, I squared basically just means if we square a square root of -1, that turns into just -1. It could have been Wise. You know, Wise does look like me. Maybe he had the monocle on the wrong side. And then, let's see, I to the third power. This is where you'll start seeing a pattern here. If we have I to the third power, we know that this can be written as I times I squared. And if we know that I squared is -1, this is just I times -1 or -I. During your first semester in uni, you had to do math which included differential equations. Remembering it triggers a fight or flight response in me. Look, I know, like, differentials exist in calculus, but, like, I don't remember ever taking a class on differential equations. Every other person that I know tells me, like, about war stories, and I'm like, I sit here, like, in my ignorant bliss being like, yeah, I took Calc 1, 2, and 3, abstract algebra, and linear algebra, I think. I think those were all the math, like, the main, like, the curriculum of math courses I took. I honestly just... I've been so far removed from college for so long. I think when I took linear algebra, that had to have been 8 years ago. Holy shit. Like 8 years ago. It's okay, you took them, don't understand them either. You failed math once in college and passed with a C the second time, or was it twice? Look, sometimes math is hard, Akio. I feel you. Differentials and integrals in calculus are easy and fun. The solution to the equation is included as its own differential is dumb and shit. Yeah, no, I can do integrals, right? I can do integrals. If you ask me to do by-part integration, I might start curling into a ball and crying. If you ask me to, like, do, like, double integrals, I also might start crying. But, like, when you're in Calculus 1 and they introduce integrals, you're like, oh, wow, it's fun. It's just derivatives, but backwards. And then, like, everything starts happening. And then they start talking about washing machines, and you're just like, am I still in math class right now? Why are we talking about laundry? Never should have taken that everyday math class. Now I'm doing equations to split up a pizza. Me on a sharp academic decline in early American-wise high school because they kept on putting me in advanced classes. I've seen that happen to a lot of people, actually, that, you know, they put you in advanced classes and then it just ends up being like, it's like when you're playing a video game and hard mode is too hard but normal mode's too easy, so they just put you on hard mode and it's just like you just fall behind because it's so much of a struggle. I feel that. Do a double substituted differential. I don't know what that means, Caleb. It's been too long. Calculus 1 is my favorite math class, actually. I agree, Conrad. In college, you went to your math final with an A-. After the final, you had a D+. Wait, how does that happen? How does it affect... Oh, right. Certain colleges just make, like, their final cost, like, 50% of your grade. I hate that stuff so much. It's like you go from being very good to being above average at best. I hate that, too. You only passed your math class because there was an essay at the end. Thank God. I think I remember that. I think I've seen that in, like, certain math courses where, like, they have you just write an essay, and that saves a lot of, like, the people who aren't as good as math, but they're good at other subjects, so they can just write themselves out of the class. You can build a functional tank and other vehicles in Gmod. You like, built redstone.
No.
Yeah, like, yeah, you know. I built redstone contraptions and I work with Blueprint and Unreal, but the math numbers don't mean anything to me. Honestly, fair. It's the reverse for me. Like, I don't understand how people, like, build and program big contraptions like that, but I can do math. I can do simple math. Anyway, if we follow this chart here, right? If we approach I to the 4th power the same as we followed I to the 3rd, we can split it up into I squared times I squared, which, as we know, is -1 times -1, or negative times a negative is a positive, or 1. So what this means here is that if I were to give you any I to any power, everything revolves around this chart here, right? If I were to go to I to the 5th power, right, we know that I to the 4th is 1, and I is the square root of -1. That becomes 1 times I, or I. This loops around, so anytime you get to any power of I greater than 4, you basically just divide that number by 4 and take the remainder, and that tells you what it is. For example, if I had I to say let's say the 62nd power, right? I wouldn't just keep on writing this chart out multiple times, because this chart loops. So if I do 4 divided by 62, because there's I to the 1st, 2nd, 3rd, 4th power, permadeath math cram section, let's go. Dude, that's what math cram sessions felt like the day before a final. I remember, like, having an emotional breakdown, like, the night before my Calculus 3 final. I had to do an entire big project for my gaming club. Like, I had to put together an entire scrapbook, and I put it together, and then I started studying for my math final, and I just started crying. I think that was the only time I ever cried because of school. I was like, oh my god, I'm so fucked, I don't know anything. And then that teacher just passed me on with a C-. Oh, that was horrible. But the scrapbook came out really well. So if I divide this, 4 goes into 22 5 times, and 22 minus 20 is 2. So when we do this long division, we can see that I to the 62nd power is the same as I to the 2nd power. You really didn't take a proper final unless it made you vomit. You're so right. You're so right. Unless it caused you bodily harm. Could you really say that you were in college taking a final? You didn't volunteer for this, your brain fucking hurts. It's alright, pup. This is like the kind of stuff that'll be on the second half of the the second half of the Math Olympiad. So we know that I to the 62nd power equals -1. That's it. That's imaginary numbers in a nutshell. I guess we could talk about complex numbers as well. These are all going to be lumped into the same category. Some people will get stuff on just finding out the value of a high exponent imaginary number. Some people might just get combining like terms with a complex number. Complex numbers. You know, it's called complex numbers, but combining them is like really easy. So complex numbers are expressions in the form a plus bi, right? You know, so for example, we could have 3 plus 4i, or say 5 minus 6i. These are complex numbers, right? This will be on the part where everyone fails, don't worry. I'm not sure if I heard that correctly. No, I mean, this is the start of the harder part, right? This is like, you know, this is like, I wouldn't even call this a difficulty spike. I don't think imaginary numbers are too bad, right? Like something like this, like I could give you something like, say, add 2 complex numbers together, right? 3 plus 4i plus 5 minus 6i, right? And I would say simplify the expression, right? Okay, now we're getting into AC. Time to bust out No, I'm not going to the complex coordinate plane, Caleb. You can't make me. You know, you were kind of good in biology, and with your exam, there's this oral part of the exam, and I just black out. So, oh yeah, I can't even see the ball. Sorry, Pup. So they were like, can you explain difficult subject? Can you maybe explain photosynthesis? Do you know what a bird is? I'm so sorry. Alright, Caleb, you really want me to go onto the complex number plane? Alright, fine. Fine, we're gonna combine this. We have 3 plus 4i and 5 minus 6i. So we combine our like terms here. 3 plus 5. Everyone in the chat, tell me what 3 plus 5 is, because I'm sure we can all do 3 plus 5. I'm sure every one of us here knows what 3 plus 5 is at the very least. It's 8. Thank you. Thank you, everyone. Thank you. You all fail. Except for Auxilla. Anyway. Then we have 4i plus negative 6i. So remember, plus negative means that we're just subtracting the number here. 4i minus 6i is minus 2i. Oh no, I'm being targeted by the rest of the class. It's like in Tetris 99 when you're the one person, like 99 people start targeting you. Auxilla's like the only one giving the right answer, and everyone else just types bullshit. Everyone just gives them the death glare. So let's make a funny table here, right? Let's make a funny coordinate plane here, just for the thrill of the sport, you know. That's not what I wanted. You feel like there's gonna be a very simple addition question? Let's get. It's alright. It doesn't start on addition. It's the whole thing's gonna start on multiplication, and if he gets it wrong, I'll be a little upset, but multiplication's hard, so I will be understanding. So, as you guys know probably, 1, 2, 3, 4, 5, 6, 7, 8. There's like the coordinate plane, right? You have X and Y. 3, 4, 5, 6, 7, 8. So this is, let's say this is 8, this is negative 8. So this is what we call a coordinate plane, right? Our X values goes left to right. However, I'm going to give him a chance. He can do multiplication. I believe in Atlas's ability to do 2- and 3-digit multiplication. I think everyone else just doesn't believe in Atlas. And then we have our other coordinate point, or our other axis, 2, 3, 4, 5, 6, 7, 8. And this is not 8y. This is 8i. This is the complex coordinate plane because Caleb wants me to talk about this 1, 2, 3, 4, 5, 6, 7, 8, negative 8i. So when it comes to imaginary complex numbers, we have to graph them on the complex number plane, right? So 3 plus 4i means we go 1, 2, 3 to the right, and plus 4i means we go up 1, 2, 3, 4. And this coordinate here is 3 plus 4i. And then we also had 5 plus 6i, right? So 5 is over here. And then we go down 1, 2, 3, 4, 5, 6. This is 5 minus 6i. So if we were to combine those together, we would simply just go from one of these points, right? Say 3 plus 4i. We go to the right 1, 2, 3, 4, 5. And then down 5, 6. And here, this is essentially the sum of the 2 points. If I add these two distances together, their sum goes over here. This is not going to be on the test. I just wanted to explain what Caleb was talking about so that we can just see what it means to graph a complex number. He spells cologne like a... No! Please! I have faith that Atlas is better at math than he is at English. I believe it. Actually, I was going to save this for tomorrow, but on the Google sheet that I had everyone fill out for information on their mathematical abilities, one of the questions was, what's the highest level of math you have taken? Atlas's response was, wait, there's levels? He can survive, I think. I think he'll survive. I believe it. I believe Kaji being good at English. Yeah, I mean, he was also 3rd place at the spelling bee and everything. So I believe in his ability to do well. I believe in his English understanding. Anyway, so that was the first topic. I can see the numbers now. What? Did I say something weird? Oh, wait. Who was second then? I forget. Why, yes, I do math on the Dante Mazai level in Mermaid Melody. What? Am I forgetting who first and second was? I thought Kaji... Was Kaji second? I thought you were second and Kaji was 3rd. Anyway, let's go on. Let's talk about another topic here. How do you guys feel about function operations, right? This is actually a bait. Function... Oh, wait, no, you know what? We're gonna do function operations. We're gonna talk about end behavior of polynomials. Another easy topic, as long as you figure out the pattern. You don't think you're in any state to do math? I don't feel like feeling them. Can't spell function without fun. Exactly. Can't spell polynomials without nom, because I'm feeling a little hungry. Actually, no, I had a pizza right before going on stream. I had a very nice high-rise crust pizza with pepperonis and meatball and mushroom. I'm pretty satisfied right now. What did I just call your mother? Yeah, polynomials. Anyway, so right. In, like, Algebra 1, you really only focus on a couple kinds of graphs. You only focus on linear functions and quadratics, right? Like, a quadratic graph looks like this. A linear function looks like this. And, I mean, you also have exponential functions, which look like this. But exponential functions aren't usually considered part of the polynomial family, so we ignore those. Bwomp, bwomp. So, what polynomials are? B squared equals 2ac. What? Anyway, polynomials like multiple numbers. So let's talk about, I think it's b squared equals, that is something. I forget what formula that goes with though. I'm forgetting because I haven't used that formula in a while. I think. Like I'd imagine I'd do something with a square or a triangle. Oh, that's not law of sines, I don't think, right? I don't teach law of sines and cosines because it never pops up in any sort of state testing, so I just ignore it. But a polynomial is a function function composed of multiple terms. Hence the term poly. Function. Fuck. Of multiple terms. So, for example, hey Chanyu, a polynomial could be, say, let's say 3x to the 4th minus 5x to the 3rd plus 2x squared minus 3x minus 20. This is a polynomial, right? We can see there are 5 different terms here. And what we're going to talk about here, what this topic is going to be, is how do we tell what the graph of this polynomial is going to look like, right? What is the end behavior of this graph? So, polynomials, right? Polynomials have a couple of different graphs. They can look a variety of different ways. Some of them look like this, where they go in a sort of N shape like this. Some of them can go like a backwards N. They look like something like this, right? Depending on some specific properties, they can look like this. Sometimes they look like this, like a W. Sometimes they can look like an upside down lowercase n like that. There's a bunch of different ways that polynomials have like different end behaviors, and we're going to talk about how do we tell what the end behavior is. And what the end behavior is what ways does a graph go to the left and to the right when everything is said and done, right? So we can see here, this graph, as it goes to the left, goes down to negative infinity. As it goes to the right, it goes to positive infinity. Or we could simply say, as this graph goes to the left, it goes down. As it goes to the right, it goes up. As this graph goes up to the left, the graph goes down to the right. Here we can see that on both left and right sides, this graph goes upwards, and here this graph goes downwards. I just accidentally drew it like anyways. So let's talk about how do we tell what the end behavior of a polynomial is. How to tell end behavior. So let's take a look at the following function. Given, that was supposed to be a v, but it ended up being a really small v. Given, let's say, 3x to the 3rd minus 2x squared plus 4. We have a polynomial here. The only thing that ever matters for the end behavior of a polynomial is this here. So what we have to look at is what we call the leading coefficient. I can't spell. Why can't I not spell today? Why am I having so much trouble spelling? Coefficient. And the degree. Degree. So they're very simple things here. The degree is simply highest power the master of numbers scrub with words, please be nice to me. The degree is the highest power, and the leading coefficient is the number in front of degree. So we can see in this problem here that the leading coefficient is 3, and the degree is also 3 in this case. Let me just actually make this a 4, just so that I'm not like mixing people up with like the same number twice. It's kind of a rude move to do here. That up, and let me just make this a 4, just for the sake of clarity. So this is 4. And now what we have here, right? So what this tells us, how to determine the end behavior is the following. Is the leading coefficient positive or negative? And is the degree odd or even? By seeing this is essentially all we need to know to determine whether or not a a function has specific end behaviors, right? So something like this, for any polynomial, no matter how big the polynomial is, all you ever have to do is find what is the highest exponent and what's the number in front of it. That'll tell you what the end behavior is. So we have this little table here. We have LC and degree. God, I've had to make this table so many times for my students over like the past what? I don't know how. We were on this topic and adjacent stuff for like a month. I just have to keep on making this table. So if the degree is odd or even, and then if the leading coefficient is positive or negative. Pretty simple table. Ooh, I cut off a little bit. Let me move this. Let me sort of just drag this to the right a little bit so everyone can see what I have here. Yeah, this works. This works. This is good enough. I only cut off a little bit of words. Anyway, so if our degree is odd, you know, say we have something to the third power and the degree is positive, that means we call this down, up. So, you know, left, right. So on the left side of a graph, if a degree is odd and positive, it looks something like this. Down and then up. On the left side of the graph, it goes downwards. On the right side of the graph, it looks upwards. Whatever happens in between happens. That's not what's important. We're only looking for the end behavior. We're looking at what way does a polynomial go as it travels into infinity. Now, if it's an odd degree, let's say here, but say that, what if this was negative 4x? Instead of down, up, we would say that it goes up, down, down. So it goes up to the left side and down to the right side. That also got cut off. Something like this. So on the left side of the graph, it's going upwards. On the right side, it's going more downwards. And for evens, evens are pretty simple. So the graphs of even functions, if, say, my exponent was like, maybe say we took out the 4x to the third here and just looked at negative 2x squared plus 4, since that's a negative with an even exponent, it would go down in both directions. Down, down. It would look just like, a frowny face, kinda. And then if it was even, it just goes up and up, and that's just a parabola. Up, up. You know, when people do a jump and they say, or like you throw a ball and people say that has a parabolic arc, that's what it, that's just an even function, right? That's just a quadratic function. Pretty simple, pretty straightforward. There we go. That is an even function. Can I not deselect, or I have to hit check? There we go. So that's polynomial end behavior, right? That if I were to show you a polynomial function and I were to ask you, how does this graph trend towards the left and to the right? You would just have to say something like that, right? You would have to sketch out a very simple graph. I wouldn't be like a stickler for it. As long as it went in the right directions, both left and right, that's really all I would be looking for. But then, you have to talk about not just polynomials in that sense, but also, we're going to talk about zeros. We're going to talk about, we talked about long division earlier. We talked about it last stream, right? Now we got to talk about something called synthetic division. And this may or may not ring some bells. I think some places teach this, some places just teach polynomial long division. But we're going to go by what I teach here. Synthetic division. I believe this does come up in calculus quite a bit as well. When you're looking for zeros, I believe you do have to do this. I'm not sure if I recall doing it. Synthetic division is based. Well, Conrad, I'm sure you'll be fine for this, right? So let's say we're doing the following division problem here. Let's say we're doing like 5x squared minus 3x plus 12, right? And we wanted to divide this by, I don't know, let's say x plus 3, right? So what the fuck does this mean? How do we do this? We're trying to figure out how many times does x plus 3 go into a function like this. And to figure that out, we first need to think about our divisor here, what we're dividing by. And what we need to think about is, what would I plug into this side here to make it 0? If I have x plus 3, how would that be 0? And that's pretty straightforward because, you know, you could just subtract 3 from both sides of the problem. And you would get x equals -3. And that's the basis for what we're going to be dividing by here. We're going to create this funny little box. I'm going to put a -3 there, because that's what cancels out this here. And we're going to write 5, -3, and 12. And if we set this up, to do synthetic division, it's a little similar to long division, but a lot faster. We gotta just drop down the first term here. You get 5. And then we do -3 times 5. And that's simply just -15. Then we do -3 minus 15 is -18. And then again, we multiply back up here. -18 times -3 is +54. And we add that together and we get 66. Or an answer of, what is it? 5x minus 18. And then here, if you remember back when we were doing long division the other week, we still have this remainder here. We have to think about how we put that remainder in properly. Before, like I said, with like long division, we could just write R66 and that would be fine. For synthetic division, that's not the case. We have to remember that we're dividing this all out by x plus 3 in the first place. So we would have to put a plus 66 over x plus 3. That's it. If this was 0, then we would have no remainder, and our answer would just be 5x minus 18. But not every problem won't have a remainder, so that is our answer here. That is synthetic division. We'll do one more example of that just because, you know, just to show it with a bit of a longer problem here. Let's say I want to do something that is going to work, but while I can usually make problems that aren't going to have a remainder, I can't do it on the spot as quickly as I was when I was like teaching it like earlier in the year. Let's say 3x to the 4th minus 5x to the 3rd plus 2x plus 1. Let's try something like this. And we're going to divide this by x, and let's pick x minus 3. So if we go for this, right? X minus 3, to cancel that out, 3 minus 3 is 0. We make the box with 3. And then we look at all of our exponents. We start out with 3x to the 4th. That's going to be 3. 5x to the 3rd, -5. And if you notice, this is just 2x. There's no 2x squared. But when we do synthetic division, we need to make sure we include every exponent from the top. 4, 3, 2, and 1. So if there is no x squared here, we need to make a placeholder of that with 0. Then 2x. Then 1. Or not 2x, just 2. And then 1. So synthetic division I think is interesting because I feel like there's a lot of things in math that, like, after you're done doing math for a long time, there are things that you'll remember. You'll remember, like, basic division and multiplication, and I think even, like, solving equations is, like, not something that you lose too quickly. But if you're not, like, if you don't commit this to memory, I think a lot of people do forget how to do synthetic division and polynomial division in general, which I could imagine that this might trip some people up if they don't catch the study session beforehand. So 3. We drop down to 3. 3 times 3 is 9. -5 plus 9 is 4. 4 times 3 is 12. 0 plus 12 is 12. 12 times 3, I should have put a negative number in here. 12 times 3 is 36. 2 plus 36 is 38. And then 38 times 3 is 114. So we get 115. Very simple, very straightforward. It's just drop down, multiply, do the combination, and keep on multiplying by that box there. It's not hard, but it's definitely something that is like something that I didn't remember until I like taught Algebra 2 for the first time in like a year. So it's just one of those things, right? Like, I feel like there's a lot of things in math that's just, it's not hard to do, but if you don't remember how to do it, you're going to be shit out of luck. So then we have, since we started out with 3x to the 4th and we divided by x, as we know, if I do x to the 4th divided by x, this turns into x to the 3rd. So everything just goes down in exponent, with our final answer being 3x to the third plus 4x squared plus 12x plus 38 plus a remainder of 115 over x minus 3. And that's synthetic division. So for the Algebra 2 section, the topics for that round are probably going to be complex numbers and synthetic division. Obviously, we can't spend time on every single topic in every single section of each math. Obviously, the longer it goes on, I might have to reach back and like dig for some stuff, but I want to be able to focus on a little bit from each topic beforehand, just to give everyone a fair fighting chance, you know? So speaking of, let's move on to the next topic. The next topic is going to be, your dad is amazing at math and can do a lot of stuff from memory. I don't know what they taught at my schools because I retain none of it. It's just a shame. Some people just do remember things better than others, right? It's like, I'm sure that there's things from school that you retain that might not be math, but like it might be your like history or your language classes. Like for me, I did retain a lot of math and a lot of physics because I was really invested in those classes, but like I don't remember anything from chemistry or bio. Like if you asked me to remember any sort of detail from those classes, I'd be like, I don't fucking know, dude. Don't ask me, don't look at me. I teach math. If you get into engineering, they will make sure you never forget numbers. I never got into engineering. I got filtered by computer science really hard. I wanted to go into game design like ages ago. I wanted to be a game designer, and then I realized I can't code for shit. I'm not doing this. I can barely handle recursion. So here I am. Though it was always like, I was always like on the fence of whether or not I wanted to go into education or game design. There was like a long period in time where I actually, instead of being a math teacher, I considered being a music teacher. I used to be like really invested in like band and orchestra, but that, I was like, I think it'd be easier to get hired as a math teacher than a music teacher. I heard that engineers get a ring that stabs them to remind them that their lives are on the line. I have never heard of that. You also got turbo filtered by comp sci, so you went to finance. Understandable, honestly. Finance is also a reasonable route to go. Everyone needs accountants and like that kind of stuff. So it's a reasonable route to take as well. I just knew I like teaching, and math teachers are always going to be in high demand. So I'm just gonna pick a safe job to be in. Let's take a look at this. Trigonometry. Right, sometimes it's its own class, sometimes it gets split apart in Algebra 2 and Pre-Calculus. But trigonometry is like pretty simple. You know, if you've ever played The World Ends With You, my favorite character, Shomi Namimoto, make sure you never forget trigonometry. Gotta remember like sine, cosine, and tangent. Oh, that song from Red Dead Redemption 2, what? Is there a song with a title that sounds like trigonometry? So anyways, trigonometry is the study of triangles. Triangles and their angle relationships, right? And trigonometry, typically when we teach it, focuses on a right triangle. One right angle and the relationship between the two other angles in the triangle. So I'm going to call this angle A. Actually, no, I'm going to call this angle B because I'm going to use the letter A later on. So with trigonometry, we break the triangle down into the parts in relation to the angle that we're looking at here, right? So we have angle B here. And we know that this slant line here across from the right angle, this is what we call the hypotenuse. Hypotenuse. The hypotenuse is just the longest side in a right triangle. That's really all there is to it. It's the side opposite to the right triangle. The hypotenuse is always going to be the longest side. And then, looking at angle B, we can see that angle B is made up of these two segments here. This over here, and this on the bottom. We can see that the side on the right isn't connected at all to angle B. So what we call that other side here, this side here is what we call the opposite side. Opposite side. And this here, the side that makes up B that isn't the hypotenuse, we call this the adjacent side. So we have the opposite, the hypotenuse, and the adjacent. And what trigonometry does is it focuses on the relationships of two of the three sides of these triangles. Depending on what pair of sides we are, we have different functions here. We have sine, which is the relationship of opposite divided by the hypotenuse. We have cosine, which is the adjacent over the hypotenuse. Trig with non-right triangles were a nightmare. So much scratch paper use. Look, I am a law of sines and law of cosines anti. If you make me do trig functions with non-right triangles, I will cancel you on twitter.com. I am not joking. We are not going to get into this. Any trigonometry that is done on this channel is only going to be done with right triangles, because I just don't want to think about that. I don't have the willpower to do that right now. I haven't taught it at all this year, last year. I think the last time I taught law of sines and cosines might have been like 3 or 4 years ago, because it's just not part of the curriculum anymore. We don't need to know it, so why would I ever teach it? Get that stuff away from me. And then we have tangent. And tangent is adjacent, or opposite. Opposite over adjacent. Very simple, right? So if I gave you, instead of just saying opposite hypotenuse adjacent, let's say that this triangle had the side lengths 3, 4, and 5, right? So if I were to say something like sine of B, we know that the opposite side is 4. We know the hypotenuse is 5, so opposite over hypotenuse, sine of B is 4 over 5. Simple. Very simple, very simple, very simple. It's just you're relating the two sides and putting the numbers there. If I asked you for cosine of B, adjacent over hypotenuse as cosine is, cosine B would simply be 3 over 5. Or 5. And then tangent of B, opposite over adjacent, your good friend Sokotoa, exactly. Opposite over adjacent is 4 over 3. Something to note about sine and cosine is that you know you're fucking something up with the ratios there if your denominator is ever smaller than your numerator. Because for sine and cosine, the denominator is always supposed to be the hypotenuse, which always canonically has to be the biggest length in your triangle. So that's always a way to make sure that you're getting the right numbers there, is that the bigger number always is on the bottom for sine and cosine. Tangent is a little different because the opposite and hypotenuse don't necessarily have to be longer or shorter than one another, so that'll always change up. But for sine and cosine, you're always going to need to have the denominator on the bottom. And yeah, my good friend Sokotoa, as they say, it's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Sokotoa. Or as they say, some old horses can always hear their owner's approach. Do the math. If the triangle doesn't have a right angle, bisect it so that it does. I refuse to do it any other way. Exactly, Cement Pinata. Bisect it, and then just add up the lines together on the bottom. I actually use tangents when drawing. In your case, it means lines that are positioned in a way that makes the drawing harder to read, so I know how to avoid them. I assume if you're using it when drawing, right? I assume it's like when you use tangents in drawing, it's like something like this, right? Like, say you have a curve here. I assume the tangent line is just the line that is, right, perpendicular to any given curve. That's usually what it is when it comes to, like, shapes and design, is that the tangent line is supposed to be perpendicular to the point that you've chosen. Will we need to learn how to label a unit circle? I'm not going to make you label a unit circle from scratch, but yes, there are going to be unit circle related problems here. The trigonometry section is going to focus on right triangle trigonometry and the unit circle. I am just going to ask you, what is the square root of 3 over 2 on the unit circle equal to? And you will have to answer. And if you don't, you will just get vaporized. So you better study your unit circle. Yeah, that's trigonometry. And then I can also give you some other problems. Actually, no. I want to try to make this whole event as non-calculator reliant as possible. So I'm not going to ask you to calculate lengths with trigonometry. I'm going to ask you to just set up the problems, but once the problems are set up, the number doesn't really matter that much as long as everything's positioned correctly. So let's say we had something like this. Let's say we want to solve a right triangle. Solving right triangles. So let's say I had a triangle and it looked like this. And let's say that we have the right angle here. Let's say this is 47 degrees. let's say this is x, and let's say this is 12. So if I gave you something like this and I asked you to solve for x, right? We know that we have 47 here as an angle. That's the angle that we're looking at. 12 is the hypotenuse because it's across from the right angle. It's the longest side here. So this is the hypotenuse. And x we know is the opposite side because it's across from that 42nd. And like I said, we have SOHCAHTOA. SOHCAHTOA. So we have opposite and hypotenuse, O and H. That means for this problem, we're going to use sine. Sine is opposite over hypotenuse. So we do sine of 47 equals x over 12. And to solve for x, all we would need to do then is simply just multiply the 12 off to isolate the x. 12 and times 12. So x equals 12 sine 47. Very straightforward. If I were to ask you to solve a right triangle, that's really all I would ask you to do is just isolate the x value and make sure that you understand what trig function you have to use to set up that right triangle. It's not too hard, it's not too bad, as long as you know how to label your triangle properly. That's really all there is to that, honestly. That's really, it's like the first part of the trig problems, right? It's going to be like that, and then we're going to take a look at the unit circle, right? Which, oh, God. I'm trying to think, like, how do you speedrun talking about the unit circle? First of all, we have to explain special right triangles, which, goddamn, I don't want to do that. I don't want to do that, but we're going to have to. So, in trigonometry, right, I said that we don't need to use calculators, and we don't need to use calculators, but there are certain ratios here that you'll see with right triangles. Special right triangles. Let's talk about this. Let's talk about this somewhat briefly. There's two kinds of special right triangles here. The first one looks something like this. Ooh. Looks something like this. So we have a right angle, and it's 45 and 45. So the ratio of sides here, no matter what, no matter how this triangle is set up, is drawn as the following. It's a ratio of x, x, and x root 2. And the way we could prove this is simply by just creating an isosceles triangle and filling in some numbers here. I'm going to do this very briefly. Let's say that we had a right triangle, and let's say that the two side lengths were 5 and 5, right? So we're going to get into the Pythagorean theorem here. Does anyone remember the Pythagorean theorem? Does anyone remember that? Any of you old geezers far removed from math remember what the Pythagorean theorem is? When we have a right triangle, and we're trying to find the last side of it, given two other sides, all we got to do is the following. A squared plus b squared equals c squared. And in this case, both our a and our b are 5. So that's 5 squared plus 5 squared equals c squared. Or 5 squared, we know 5 times 5 is 25. 25 plus 25 equals c squared. Or c squared equals 50. How does that apply to this x root 2 thing exactly? Pretty simply put, all we gotta do is the following. Pythagoras. If we take the square root of both sides to get just c, we get the square root of 50. And to break that down, we know that 50 breaks into 25 and 2, and 25 breaks down into 5 and 5. And we know that if we wanted to cancel out roots here, this is telling us that the square root of 50 is the same thing as root 5 times root 5 times root 2. Again, 5 times 5 would be 25, 25 times 2 would be 50. So these are effectively the same thing. But we know that the square root of 25 itself is just 5. 5 root 2. That's a 45, 45, 90 triangle. 5 root 2. The two legs are the same value, and the hypotenuse is the same thing, but it has a square root of 2 attached to it. And that's going to be important on the unit circle because the unit circle, when we're at the 45-degree angle, actually looks like this. It has a hypotenuse of 1 and its side lengths are root 2 over 2 and root 2 over 2. That's it. That's it. You know, all you gotta do is just remember these properties here. That's a 45, 45, 90 triangle. And this is a other special right triangle is a 30, 60, 90 triangle. I would explain more in detail, but as you know, this is a cram session here. We gotta be able to go speed through this. If you have any other questions, you can see me after class, if you know what I'm saying. I can't wink. I can't wink. Why can't I wink? There we go. So there was a 45, 45, 90 triangle and the 30, 60, 90 triangle. This one's a little bit easier to explain. So the short side of the 30, 60, 90 triangle is always what we call x. The long side is what we always call 2x. And the taller side is called... Are you pointing a gun at me? I'm being threatened. Help. The teacher's being threatened with gun violence. In this day and age, come on. I shouldn't have to see that. So basically what this means is that if we look at the unit circle, we know that with the ratios of 30, 60, and 90, that if we have a length of 1 here, we know that the short side is always going to be half that value, so this is going to be 1/2. And if this other side is always going to be x times root 3, 1/2 times root 3 is root 3 over 2. So what this means for the unit circle, right, is that I could ask you a question looking at the unit circle like this. Hey, Sovereign Incognito, welcome. We're just doing some math right now. Let's say I gave a coordinate plane like this. Let's go like this. The unit circle simply is just a circle whose radius is always 1. And let me just draw it like this. This is like almost a circle. I can draw perfectly fine. I know how to draw shapes. I'm a math teacher, not an artist. Be nice to me. Alright, and so we have, let me just draw the lines here. And there we go. So if I have a 30-degree angle, holy shit, that is not a 30-degree angle. All you need to know is that the coordinates for this, if it's 30, we know that this shorter side is 1/2, while the longer side across the bottom is root 3 over 2. We know that for a 45-degree angle, this is going to be, like I said earlier, root 2 over 2 for both the length and the width. And this 60 degree is the same thing as the 30, but just reversed. So instead of root 3 over 2 and 1/2, it's going to be 1/2, comma, root 3 over 2. That's really all there is to it, right? So I could ask you something like, knowing all these values here, you have to remember that the x value is cosine because that's the adjacent side to this bottom side here. Sine is the opposite, or the y value. So cosine, comma, sine. I could ask something like, say, find, let's say, cosine of 60 degrees, right? All you would have to be able to do is refer to that 60 degrees. Looking at here, we have our x and y values, 1/2, comma, root 3 over 2. Cosine of 60 would just be 1/2. And that's it. There's no complicated calculations there. All you have to do is simply just memorize an entire table of values. And if you're in a math competition, I feel like that's not asking too much to know about all that. Right? Right? I'm sure everyone participating is fully aware of the unit circle. I think that's as far as the trig is going to cover. I could be mean and go into like trig graphs and stuff, but then that means I also have to make problems involving trig graphs. And, you know, I started making the problems to this like last night, and I was like, wow, I really am just doing more work here. But can you use a cheat sheet? You can go by the honor system. Also, welcome, Leon. I can't see if you're Googling the answers to this or not. It's an unspoken rule of math. Do not trust the shape of the triangle. They are never accurate. Only the numbers are true. You're right, actually. because that's going to be a part of the geometry section as well. We're going to talk about proofs a little bit. But if you cheat, I can't tell unless you take like a really absurd amount of time. Been lurking your lesson, teach. I'm glad. I think it's going to be really funny for like, you know, I always like when you watch game shows like Wheel of Fortune or Jeopardy, and like you're sitting at home, you're watching these idiots play, and you're like, wow, these guys are dumb. I know the answers to all of these. But like you're like, wow, I could definitely succeed on this game show. I feel like that's what's gonna happen tomorrow. Like everyone's gonna see these questions, and like there are some people who are like really like absurdly good at math from what I can tell who entered, but there are also some people who I'm not so sure. Hi Atlas, what's up? Hi Atlas. This is the unit circle, Atlas. Make sure you take a screenshot of this and save it to your notes. All you need to know are these 3 coordinate points, you know, just in case I ask you something like, find the value of sine 30 degrees, right? Sine 30 degrees, we look at the 30-degree angle, and as it says, sine is always the y value. The value of sine 30 is just 1/2. So sine 30 equals 1/2. Maybe you'll be the lucky one who gets, this is 0 degrees, which is 1, 0, and I can ask you something like, find, what is it, like cosine of 0, and that's simply just 1. That's an easy answer, right? Or like 90 degrees, where it's 0, 1. No, I'll confuse it with the other one, easy. There's only 4 different kinds of numbers you need to know here. Or 5, I guess, if you count 0. 0, 1, 1/2, 2, root 2 over 2, and root 3 over 2. That's all you gotta know. If you can remember those 5 numbers, then you're golden. And I can't, if I had a hand cam, I could do this. There's like a little trick that I do, because if you draw a hand here, right? Like say, I'm trying to figure out how I put my hand on the board for this. So like there's your thumb here. And you got your index finger. Holy fit, that's a big index finger. And then you got your middle finger. And then you got your ring finger. And then you got your pinky here, right? So if you draw a hand, this is the most fucked up hand I've ever drawn, right? So looking here, right? We can see it's root 3 over 2 and 1/2. If I chop this finger off, you'll see I have 3 fingers on the left and 1 finger on the right. Root 3, 1. If I go to the middle one, that 45-degree angle, you'll see that I have 2 fingers left on the left and on the right. So root 2, root 2. Just notice permadeath is attacking this math room. You couldn't be any closer to the truth. Yeah, no, my supervisor taught me this one because she was like, you know, you gotta do some more hands-on things, and she literally put her hand on the board, just slapped her hand on the board, and just like raised her fingers up and down to line up with the unit circle, and I was like, holy shit, that actually works. And then even with like the pinkies, right? Even with the pinky, if you look at the pinky finger, right? 0, 1, you cross out the pinky, and you have 4 fingers left. If you keep the same pattern here, this can technically be written as 0 over 2 and root 4 over 2, and the square root of 4 is 2. So this turns into 2 over 2, or just 1. So it applies the entirety of the way through the first quadrant. So if you just look at your hand, if you just put your hand in front of an imaginary unit circle and lift up each of your fingers up or down, depending on if you're looking at 30, 45, or 60, it shows you, it tells you like what the ratio is, as long as you remember that the denominator is always 2. So it's a pretty useful trick. I pretty much show that to everyone. Like even the students who are like not good at math are able to like survive the unit circle test because they just remember that trick. It helps. And it's like simple tricks like that really like just do help those kids out a lot. So now, we've covered a little bit of trig, we've covered a little bit of algebra 2, we've covered a little bit of geometry and algebra 1 last time. We're gonna talk about derivatives. You know, I taught my pre-calc kids derivatives like over the last week to be like, yeah, calculus is easy, all you need to know how to do is this. So we're gonna talk about some basic derivatives, right? Derivatives. No, I'm not talking about limits, you can fuck right off with that. So derivatives represents I was good at the spelling bee. Represents the rate of change. I don't feel like testing people on limits on this quiz. I'm just gonna do derivatives and integrals. Those are gonna be the problems. Those are gonna be the calc sections. You won't have to derive the derivative. No, you won't. You will just have to calculate derivatives. Also, I feel like limits are easier. They are easier, Atlas. Riemann sums. I don't think I remember doing Riemann sums, if I'm going to be honest. I think that was like Calc 1 or Calc 2. By Calc 2, I was fully zoned out. I teach math, by the way. Represents the rate of change at any given point in time for a function. Right? It represents the rate of change. So, honestly, Atlas, I'm surprised you're even mentioning this, considering how you answered the Google Doc earlier. I would have expected you to have taken like up to like pre-calc and then just not taken a single math class in your university. Is like the impression that I got from your submission. But yeah, no, limits are easier. But we are just gonna go into derivatives and integrals for this Olympiad, because I feel like it's easier to just... I feel like it's just easier on me to just do that, because it's the stuff that I remember the most. So, derivatives have a couple of different rules that we're going to look at here. The first one, obviously, is the power rule. There's, like, a whole thing you gotta do to prove these shits. But there's like also these cool shortcuts. I remember like back in like when I first took calculus in high school, my teacher like didn't teach us like the derivative rules, but he taught us like, he gave us on like a test. I remember it was like, take this weird derivative, and it was like we were still doing it based off of the limit and like the definition of the limit. And I was like, how the fuck do you expect me to do this? And he was like, haha, it was a trick. If you already knew what to do, you knew, but we make this so much easier. And I was like, wow, fuck you, guy. I didn't realize I had to spoil myself in order to get extra credit on this test. We're not gonna have to do proofs. You're gonna do geometric proofs, is that what you mean? You're gonna have to remember all that geometric proof terminology. I'm gonna show you two triangles. You're gonna be, what's the proof for step 5, baby? No, we're not doing advanced math proofs. The physics route with position, velocity, and acceleration is just a lot easier. Yeah. When you just talk about it in regards to like motion and acceleration and all that kind of stuff, it's a lot easier for me to remember. I remember that a lot more than just the limit stuff. Give us a 20-term trig identity. Hey, Conrad, you can make one of those and throw it at me when you're like the last one standing, and then you become the teacher and then I become the loser of the tournament. But until then, don't do that to me. Let's say the power rule. Power rule. Let's say given. Why did I write E? Given a function. Let's say nx to the m power. Let me actually write this as a function because we do need to use function notation here. Otherwise, things get a little weird. Let's do that. And let's hit that checkbox. And let me do this. So f of x equals that. We would then just say f prime of x equals m n x. I have the, you don't need to have the x there, I just put it there just in case like a coefficient does exist. You're still just multiplying by the m times n. And then you have m minus 1. That's just the power rule there. It's very straightforward. We just do, for an example, I can just give you, say, 5x to the 4th. Let me just say f of x f of x equals 5x to the fourth. F prime of x, we just multiply the 4 down to the 5. 4 times 5 is 20, x to the third. Very simple, very straightforward. The power rule is like super easy. Even like anyone could do this. Like if you wanted to be like, yeah, I know calculus, x squared, f of x equals x squared. The derivative of f prime of x is simply 2x. I know calculus. That's it. That's all you gotta do. Then you also have to remember, if you have a constant, say the derivative of f of x equals 5, f prime of x, the derivative there is simply just going to be 0. You don't have a variable, your value just turns back into 0. There's no rate of change there, so if we're trying to calculate the rate of change of something that does not have any rate of change, then it's just flat, it's just 0. That's it. Simply put, straightforward, that's it. That's the power rule. Then we have the product rule. A little bit trickier, but still a bit easy. Product rule. The product rule is like the power rule, except, you know, if you're multiplying two functions together, then it's a little bigger here. So let's say given f of x and g of x, h of x equals f times g. So it's a product of two things, right? So h prime of x would then be f prime times g plus g prime times f. Or what this means is that if you have two terms together, two functions, multiplying them together, to find the derivative of their product, you multiply the derivative of the first product of the first term by the original value of the second function, and then you take the derivative of the second function times the original of the first. So let's say I had f of x equals, let's say 2x to the third plus 1, g of x equals 3x squared plus 5. Very simple, like just two binomials here. Honestly, if you foiled these together and just took the derivative that way, that would also work. But if we do this by the product rule, f of x is 2x to the third plus 1. So if we just took the derivative of that, that would be 6x squared plus 1 times g of x's original value, which is 3x squared plus 5, plus g prime of x now is 6x. Wait, why did I put a plus 1 there? I'm dumb. It's alright. No one said anything. No one said, teacher, you got the problem wrong. So I'm still safe. You know, sometimes I'll get a problem wrong on the board, and no one will correct me, and I'll just be like, dang, no one really was listening to me today, huh? I didn't notice. It's alright. It's alright. Sometimes it just happens. Sometimes you just see the teacher doing this thing and, like, you don't think that the teacher could be wrong, right? The teacher knows best. The teacher knows everything. So they would never steer you wrong. They would never say the wrong information. Like, why would they ever? You think a teacher would teach a class and tell lies? Yeah. Your second 6x is wrong if you want me to point out more failures. What? G prime? Kronofsky. I just assume I'm wrong always. Also, welcome, Kronofsky. Yeah, it's g of x. Come on, Atlas. Come on. Trying to call me out after I call myself out. You know, I appreciate it, though. I appreciate it. Plus 1. Gotta keep an eye out. Gotta be vigilant, honestly. GG easy. It's alright, it's alright. That's why we warm up today, so that for the Math Olympiad, you don't get filtered immediately. So 6x squared times 3x squared, that's going to be 18x to the fourth. 6x squared times 5 is going to be plus 30x squared. 6x times 2x to the third, that's going to be 12x to the fourth. And 6x times 1 is plus 6x. So we just combine our like terms, and we get 30x to the fourth plus 30x squared plus 6x. And that would be the derivative. That would be the derivative of h of x. And I will say, yeah, you can derive it by just by foiling this. Like, say, if I took 2x to the third, and 2x to the third plus 1 and 3x to the second plus 5, let's say, let me do this in a different color just so it's a little bit more apparent. So 2x to the third plus 1, 3x squared plus 5. 2x times to the third, that's going to be 6x to the fifth plus 10x to the third plus 3x squared plus 5. So 6 times 5, that's going to be 30x to the fourth plus 30x squared. 3 times 2 is 6, so plus 6x, and the 5 doesn't derive. So you can do it either way, but I will ask you to write things. If I do ask you, and how would the curve look like? How would the curve look like? It would, if I graph this out right, I would have to graph both out, actually. So the curve of this, 30x to the fourth plus 30x squared plus 6x, there would be, the y-intercept would be 0, right? The y-intercept would be 0. I know it would look probably something like some kind of curve like this. I don't know exactly what it would. Positive slope, so a u. Yeah, it's like gonna be this W shape. I don't think I'm pretty sure it curves inwards and outwards. I don't recall, because again, I made this off the top of my head, so I'm not gonna ask for graphs of the curves. I'm just gonna be asking straight up just the calculations here. So I'm just gonna make sure I can see that you can do the calculations. For these derivative rules specifically, I am going to ask you to write out the work with the proper rules, right? So if I say to derive using the product rule, you will have to use a product rule. For certain things like factoring, like in the Algebra 1 section, I'm not going to be specific, but for this, you will have to show that you are using the right rule. That's the product rule, and we're going to go over the quotient rule. Let me do this. So let me draw out, go back to white, quotient rule. So quotient. So this one's a little bit wackier. So the quotient rule is a little bit more convoluted. Let's say that given h of x, instead of being a product, it would be f of x over g of x. And God forgive me if I fuck this up. I taught up to the product rule this year for my pre-calculus class. I didn't teach them the quotient rule. So if I get this wrong, you can tell me that I'm being dumb. Or if I'm right, you can tell me that I'm a genius. I'm doing this right off the top of my head right now. H prime of x would then be f prime times g minus g prime times f all over g squared. I forget if it's g or g prime. Let me check real quick, unless someone else corrects me right here, right now. But I believe it's not g prime. I know, like, my coworker, when he teaches this, he, like, says this, like, thing like low D, high D, low, and he says that, and I'm just like, what the fuck are you talking about? Can you just use, like, function notation for this? Like, what does this low D, high mean? And I think what it means is, like, the denominator times the derivative of the numerator, like low and then D high, and then high, then D low means the derivative of the denominator over D squared. It's like, or low squared or whatever. Like, I heard my students saying that, and I was like, you mean he didn't just teach you function notation? He just didn't write it like this? Like, I think it's, like, easier to, like, see, like, low D high, high D low, I guess. Like, it sounds more, like, memorable to talk about, like, numerators and denominators, but, like, can you not just use f of x, g of x inverse, or does that not work? I don't think I've ever taken the derivative using the inverse, actually. I wouldn't know. I've just never seen that before. So I would assume it doesn't work. I don't think I recall taking the... I don't think I've seen, like, that with taking the derivative of the inverse, but if someone more calculus brained than me is here in the chat, they could feel free to correct. Yeah, I don't think the inverse works there. So let's say I have something like, let's say we have x, let's say I have x squared plus 6x plus 5 over, let's say x plus 3, right? Let's say we had something like this. So to take the derivative here, again, f prime times g minus g prime times f. So 2x plus 6, f prime times g, that's x plus 3, minus g prime is going to be 1 times x squared plus 6x plus 5, all over g squared, or x plus 3 squared. Oh, this is going to be a long one. So 2x times x is 2x squared plus 3. So it's 2x times 3 is plus 6x plus 6x plus 18 minus x squared minus 6x minus 5 all over x squared plus 6x plus 9. So there we go, right? If we combine our like terms, 2x squared minus x squared is, that's going to be x squared. 6x minus 6x plus 6x is going to be just 6x. You have 1, 2, 3. These cancel out. You're going to give us a sneaky and make the top one factorable? I am. I am. And then we are going to get 18 minus 5 is 13. Plus 13. Over x squared plus 6x plus 9. I feel like I might have messed up here, right? Wait. So 2x squared, x squared, that subtracts, that cancels out. Negative 6x. That's 6x and 6x. That's 12x minus 6x. Yeah, it's 6x. And then 3, and then 5. No, yeah. So we get this. So the derivative is simply just this, and this is not factorable. We could factor this, though. We could factor this to make this easier to work with, because if we have x squared plus 6x plus 5... Wait, no, we can't factor this one, actually. I realized I messed it up. If I wanted to make it factorable, it should have been 5x plus 6. Yeah, so it is factorable, but we can just keep it like x squared plus 6x plus 5 for peace of mind. If it was x squared plus 5x plus 6, then that would have been factorable and we would have been able to reduce it down. But either way, this is how the quotient rule works. Sad Zam. Zam. Zad. You're learning so much. I'm sure it's all coming back to you. Alright. Now this is the part where I'm going to start flying off the seat of my pants. You know, when I teach at the academy, right, I know what I'm teaching typically. I know what I have to teach. But I'm going to say, the last time I've written a lesson plan this school year, I think was in October. The last time I did a lesson plan that wasn't just copy and pasted from a previous year, I want to say might have been 2017 or 2018. Every morning I wake up, I go into the building, I recite the information from the top of my head. Thankfully, I've never had to teach a regular calculus course before, because I haven't taught calculus yet, because we've only had AP calculus, and I haven't felt the need to get certified to teach that. So I haven't, because it like requires you to like go to this thing that's like, it's like 5 days of 8-hour classes of calculus, and if I became a teacher so I didn't have to sit through classes again, right? So I'm not going to sit through an 8-hour lesson on how to do calculus just so I can teach the AP kids. So I guess teaching the AP kids would be nice. But yeah, no, it's a lot of pressure. And we already have like 2 AP certified teachers. There's more teachers that are AP certified than there are actual positions needed for AP teachers. So it would be redundant, I feel, unless I knew I was leaving and wanted to go to a district that might need to hire more of them. But let's go on to the last topic of calculus that we're going to cover. Unless, if it gets farther than this, I'm going to cry, and I am just going to start pulling out crazy things that I just have the answer for but cannot do the work for. So, I hope it doesn't get that bad. No linear algebra? Atlas. I took linear algebra, but I don't remember a single thing about it. This Math Olympiad goes as far as high school level. This goes as far as what you would learn in a high school, and integrals are the farthest that we would learn. So, integrals. You gotta give us some double integrals. I think at the high school level, maybe in like AP Calculus BC, they might do double integrals. Yeah, no. I'm not trying to do like college level math here. I'm doing things that you would learn in a high school classroom because it's also just more accessible, I think. Like, the spelling bees happen at all levels, and like, you know, you see those little kids on the national spelling bee, like, spell like the craziest words, and you're like, how the hell are these kids spelling this? And yeah, that's like basically the same thing here, though I fear that everyone here, like, I wonder like what I'll have to do to get you guys like destroyed out of this competition. Like, everyone seems roughly familiar with everything, so I might have to throw some like crazy curveballs here. So integrals simply just represent the area under a curve on a given interval. Right? It's pretty straightforward, right? And to find the integral, why can't I spell? It's the worst when like you misspell something and you like try to slide the letter in between the letter you just wrote down, and you just start spiraling out of control. You gotta do the reverse of tanking, god damn it, taking the derivative. So for example, if I wanted to just say like what an integral was, we would say the integral of, let's say, we'll do an easy one, right? So we'll do like 3x to the 4th, right? Or no, let's do 3x to the 2nd. 3x to the 2nd dx. So it's been derived, you know, the derivative has already happened, so we have to think about how we go backwards here. So we know that, given the power rule, right? If we have 3x to the 2nd, we know that 1 was taken away from the exponent. So if it's 3x squared, we know the exponent is then going to be x to the 3rd. We need to figure out, if we dropped 3 to multiply in front of x, what did it multiply to get to that coefficient? And obviously, in this case, it's pretty obvious, it's just 1. So the integral of 3x squared dx is just going to be 1x. And that's basically what we have to do. We just have to think the reverse of the power rule, and that'll help us figure out what the derivative is. So we do 1x to the 3rd plus c typically, to represent, if there was a constant there, that the constant was that. So let's say I want to do something more in depth. Let's say we want to do the integral of, say, let's say we want to take the integral of 5x to the 6th plus 3x to the 4th. Yeah, that works. Minus 6 dx. So here's our whole integral here. All we would have to do is look at this step by step here. We look at the 5x to the 6th first, right? We know that this is going to be x to the 7th. We need to figure out 7 times what is 5, right? So we would say 7x equals 5. Obviously, to solve this, we just divide by 7, and we get 5 over 7th is our answer. 5/7 x to the 7th, plus, then we get 3x to the 4th. We know that that's going to be x to the 5th. So in the same vein, this is 5/7. This is going to be, what is this? 3/5. 3/5 x, and then the minus 6, minus 6x. Really, that's all there is to it. If you see a constant, then when we take the derivative or the integral, it's going to be the variable just comes back, and then we have that plus c. And that's it. That's the integral. That's really as far as we're going to go in terms of content. At least that's the that's how far we're going to go until we start breaking away from rounds and I start making people fight each other in timed races on math problems. But those are going to be the main topics, right? We're going to go through integrals, we're going to go through derivatives, we're going to go through trigonometric functions, both triangles and on the unit circle. Will we need to solve with numbers? Yeah. You're going to need to solve with numbers as well. That would probably be the next step that I go beyond that, but I don't have any problems prepared for that. And then we have synthetic division, obviously, and behavior. And we talked about complex numbers a little bit. We talked about I. And we talked about, in the previous video, we talked about, factoring. We talked about, damn, I have all these saved. We talked about factoring to solve for 0, distribution. We talked about volume a little bit. So there's going to be a lot of these topics. It's probably going to go for so there's 10 people and there's going to be probably 10 rounds of problems. I want to see how long people will survive those 10 rounds. And then we're probably going to have to speed things up at that point. Because I remember the spelling bee. I don't remember how many rounds it went for. Will you given formula, or we got to remember volume area? You'll be given formulas. I will tell you the formulas for things like geometry and stuff, because that's just courtesy. But otherwise, no. There's going to be some stuff with exponents, so that's just naturally going to be there overall. There's going to be, obviously, things like... What is this? This was just solving multi-step equations. This is just shape properties of geometry. There's going to be a lot of math topics that we're going to be covering here. But yeah, that's really all I wanted to go through. And Very Cherry, welcome. Thank you for the follow. Yeah, that's the bulk of it, really. I'm surprised I was able to focus as long as I was on each of these topics compared to last time. But I don't want to go over some more, a lot more stuff, because there's not really many topics I want to cover. And, for people who need to watch the VOD to refresh their memories and stuff, I don't want to have a 3-hour long VOD for a study session. That just seems inconvenient. With online teaching, right? When it came to online teaching, I would post recordings of the Zoom lessons that I would do with the students, and I always thought to myself, these kids can barely pay attention in class when they're there. None of these kids are going to watch an 80-minute long VOD of me teaching the material. It's not going to happen. So to respect your time. Let's do a VTuber teacher teaching math. You found a unicorn? Well, lucky for you, actually. We are about to wrap up today. I'm glad you stopped by, but tomorrow at 12 o'clock p.m. Eastern Time, we're going to be actually doing an entire VTuber Math Olympiad. I'm going to have 10 different VTubers on here, all doing math problems to be the greatest VTuber mathematician. Because, it's commonly known, VTubers can't read, that's the joke, right? VTubers don't know how to read, VTubers don't know how to do math, VTubers don't know how to function as basic adults. But we're going to see a bunch of VTubers challenging each other, and probably me, actually, at this point. I feel like everyone's smarter than me. I feel like everyone here has, a level of competency in math that I just am wait, I forgot that was a thing. Also, I teach math. Wait. Also, this is legally my job. But, yeah, we're going to be doing that tomorrow at 12 p.m. Eastern Time. So, it'll be fun. It'll be fun to see how everyone does, It'll be like a spelling bee, but with math, because, spelling bees seem like they would be easy, but man, those don't fuck around. I'm still upset that I got destroyed by the word philtrum, because how was I supposed to know that's what the little dent in your, above your lip, below your nose is supposed to be? How was I supposed to know it was going to be spelled with a PH? I'm still upset about that one. Fucking philtrum. God. But, so as to not give you guys too much study material to refer to, I do want to cut this one a little bit early. And I want to find someone to raid. Let's see who's online right now. Let's see maybe like if a participant for tomorrow is going to be on right now. Or maybe just someone doing something fun. It is Friday. It's Friday afternoon, so prime time is starting up in a little bit. Let's see. Who can we pay a visit to? Who do I see is on my following list? Let's see. I'm gonna go and raid into... Yeah, none of the participants are streaming. Let's go and raid... Let's go raid Arya. I'm gonna raid her, because I feel like every time I see Arya online, she is like... I'm at, like, work, but, like, it's technically, like, basically, like, work hours adjacent right now, but she's playing Pokemon Unite, and I don't really get to raid into her often, so we're gonna raid Arya. So, yeah. Thank you guys all for coming. Make sure you tune in tomorrow at 12 p.m. if you want to catch everyone fighting to the death to be the greatest VTuber mathematician. But for now, thank you. And thank you guys all for lurking, hanging around, chilling, and watching me do what I literally do as a day job. This is literally my job. But let's go and pay a visit to Arya.
Introducing the Hyundai of all.
Shut up. So we'll see you then. For now, class is dismissed.